All right, hey guys. For today's video, we're going to be looking at domain and range from a couple of different types of functions on a graph. This won't be like a set of coordinates or anything discrete like that. So we're going to be looking at continuous functions and finding their domain and range using interval notation, which uses the symbols that we've been using, less than or equal to, greater than or equal to, less than, and greater than. As far as this goes for today, we'll keep this to the most simple as we can. So the domain is all of the x values of a function. We're going to use interval notation to express that. And the range is all of the y values of a function. Now, when you look at a function on a graph, it's going to have some endpoints, and we're going to be looking for those endpoints because we want to know where do the x values begin and stop, and the same for the y values. So we're going to have to be looking out for two types of points, closed circles. So these are closed points. For these, you're going to use the less than or equal to and greater than or equal to symbols. And then for open circles, you're going to be using the less than and greater than symbols. So just keep those four things in mind, and we should have a smooth start to this lesson. Let's try an example. The first thing that you're going to notice that I did was color code domain versus range, because I want to keep them separate. And making sure that you know which one is which is very crucial to finding these things. Now, as we look at the x-axis, after I talked about color coding, I messed it up. After we look at the x-axis, that's the horizontal direction. And then after we look at the y-axis, we can actually pair these up just by this color coding. And we're going to be looking for a couple of things for domain. Let's start with domain. I'm going to look for the lowest value of x that I can see on the graph. And the lowest value of x seems to start right here at -3. Okay, the next thing I'm going to do is I'm going to find the highest value of x. The highest value of x on this graph of this function happens to be 1 to +3. Okay, so if I go ahead and draw out that whole blue section, this ruler on the x-axis actually shows me the exact domain of this function. You could draw lines connecting these points to the x-axis, but at the same time, you don't need to because we can see just by shading it in or using a highlighter that we can actually find that domain. Now, the way we're going to write this domain is going to be a special type of way called interval notation. And I'll say it in English while I write it in math. So let's try this here. It's the set of all x values such that x is in between -3 and 3. Okay, and notice that I have two closed circles for my maximum and minimum here. So I'm going to be using less than or equal to signs. Okay. Once again, this just says the set of all x values such that x is in between -3 and 3. So x is greater than or equal to -3 and less than or equal to 3. Okay. We're going to do the same thing for the range. We're going to find the biggest y value this time of my range, and I'm going to use the y-axis as a little ruler here. The biggest y value that I see is at +1, and the smallest y value that I can see from this graph is at -2. Okay. So if we highlight this section, you can see that I'm using the y-axis as a ruler once again. And I know that we're looking for the set of all y values such that y is in between the smallest number, -2, and the largest number, 1. Okay, and once again, notice that for range, y is taking the place in all of these places. That's important to note, and these symbols that we use totally depend on if you have open or closed circles. Let's try one more. Okay, in this example, we actually have something a little bit different. We actually have an open circle, so this is open. Okay, for open circles, we're going to want to use the less than sign. Okay, not less than or equal to. And for this closed circle, I know that we're supposed to use less than or equal to that sign. So that's just something to note as we start. I see that open circle. That's automatically what I'm thinking. Okay, I'm going to use the x-axis as a ruler to find my domain. Okay, because I want to know where these x values live. Okay. Looking at the x-axis, the lowest number that I can see that is on this graph will be -1. I'll mark it there. The highest number is all the way over here at 4. And even though that's an open circle, I'm going to mark it as 4. Okay, because I know it's not an actual x value that's in this function because there's a hole there, thinking critically. So essentially what we need to do is the same thing, -1, a symbol, x, a symbol, and then my biggest number 4. Okay, and this time, since they're open circles, I'm going to be using the less than sign. Okay, so x lives between -1 and 4. Okay, if I look at my y-axis for the range, I notice that my lowest value is 1, and my highest value is up here at 6. So I'll mark those. Okay, so I know I'm looking for, my range is going to be the set of all y values such that y is greater than or equal to 1 and less than 6. I'm only saying less than there because we have an open circle. Okay, speaking of which, okay, that x value, -1, is actually a closed circle, so I made a mistake there. It actually should have a line underneath. It should be less than or equal to. So this is the domain and range for this function. It's important to keep in mind open and closed circles and x and y as you do this. Let's do one more. Okay, taking a look at this function, I'm going to start with domain once again. I know that if I have both open circles, both are open. Okay, so it doesn't matter domain or range, since both my circles are open here, I'm definitely going to be using the less than sign as I write my domain and range in interval notation. So if I look at my x-axis for domain, I'm going to notice that my lowest value is at -3 on the x-axis, -3, and my highest value is at +1 over here. So I mark that on my x-axis. And now I can write it in set builder notation. The set of all x such that x is in between -3 and 1. Okay, now are these the right symbols? I know that they are because my lowest value and my highest value both have open circles. So that's exactly the symbols we need. Using the y-axis, I see that my lowest value of y is at -1. +1 once again. And then my highest value is at 5. So all my y values live between 1 and 5. So the set of all y such that y is in between 1 and 5. Okay, and I know that I should only be using less than signs, so this is actually the domain and range for this function. Let's do another one. I keep saying one more, but we're going to keep going. Okay, I like this example because it's not a straight line. This is actually a exponential curve. Okay, so this is growing faster than a line would on a graph, but that's not important for this lesson. What is important is this arrow. On lines, this means it goes on forever. This is true for this function as well. So this goes on forever. Okay, and when I say forever, I mean forever to the right and forever upwards. Okay, so you can imagine this extending off all the way to infinity in the x direction, all the way to infinity in the y direction as well. So it goes off in both to the right and upwards forever. However, it's not it's not an infinite graph, so to speak, since we have this part here chopped off at the coordinate -1, 2. Okay, this will make things interesting as we draw our domain and range. First of all, I know at least for the domain, my smallest x value is definitely at 2. I know my smallest x value is definitely at 2. However, if we try to paint the rest of this axis, you would notice that this would never stop. Okay, since this function goes to the right forever, okay, so does its domain. Okay, now the way to describe this is the set of all x such that x is greater than or equal to, since we have a closed circle here, greater than or equal to the number 2. Okay, and it's as simple as that. It's really just all the x values that are greater than or equal to 2. So a simpler way to describe this domain, at least. The range, if I look at my y-axis, it reaches down to -1. Okay, and once again, we get this situation where it's going to continue up forever. Okay, so the range will never stop. Okay, starts at -1 and goes on forever. So the way we would describe this is the set of all y values such that y is greater than or equal to -1. And we use that symbol once again because we have a closed circle at that limit. Okay, this will be our last example. Very similar to the last one, we have a curve instead of a line, but that won't stop us here. I know that I need to look for my lowest x value on the graph on my x-axis, use it as a ruler. And just like the last example, this one has an arrow indicating that it's going to continue upwards and to the right forever. So I know that that is the case with my domain as well. My lowest x value is at -1, okay, and it continues off into infinity. So I would describe this as the set of all x such that x is greater than or equal to -1. And very similar, my lowest y value actually this time is at 0. My lowest y value is actually at 0 this time. So starts at 0. The arrow on this graph tells me that my range will continue on forever in that direction. So I know that we're looking for the set of all y values such that y is greater than or equal to 0. Okay, by the way, we use these symbols both times because we have a closed circle on the end. I hope this video was helpful. Make sure to look at the anchor charts on Canvas, and I hope this helps you review for your test. Thank you guys. See you later.